Hello and welcome to Pump Video Academy Online. My name is Nelik and you are looking at the issue of the Pump Video Academy module PVA-4. That module comes in response to the feedback we received from the readers of Pumps and Systems magazine September issue, the article called How Much Energy Do Pipes Remove? On pages 24 through 26, and specifically the answers on the reader's feedback will be published at the October issue of the Pumps and Systems magazine. And when you read that feedback, you'll have to have original article in front of you, or we'll flash a couple of pages from this article just for general reference. And primarily, the feedback on the article came from several users. One of them is our continual contributor, Mr. Lee Ruse, and his feedback is presenting the bulk of the publication material on the October article. So the article that appeared in September essentially looked like this. It had, on the first page, we have a flow, and in the example of the article, we considered 8,000 gallons flowing through a roughly 5 miles of pipe, 18 inches diameter, and it showed that it consumes $1.3 million if the pump operates non-stop. Now, the input to the program is reflected in this paper, and we need to look at the program itself in order to line up this particular paper, which I'm just flashing on the screen for general reference point. It's a little bit difficult, I realize, for you to read as I'm only keeping on the screen for a brief time, but I'm going to switch into a program itself in a moment, and that will kind of become clear. So I'm going to the program itself. So what I'll do is we'll go to our website. We'll go to pumpmachinery.com website, and under the Pump Magazine tab, click on that. We'll see another tab called Pump Programs. Click on that. Several programs come up, and from which one is called pipe loss, to calculate losses in a pipe, friction losses, and then a pump head required to overcome the friction losses at a given flow and through a given diameter pipe. And then another program, a sister program, but separate, called Pump Efficiency, calculates pump efficiency for a given flow and head for a typical pump, almost regardless of the type, whether it's a vertical, end suction, double suction split case. That's a quite generic calculations, rather accurate. So let's go to the pipe loss program first. So we click on the icon. The screen will open, and we will see the first on top of the program. We'll see a procedure how to run this program. And essentially, as it say, we'll make a rough first guess on a pump efficiency. And here below, we'll see two sets of tables. The first for a new pipe, and the second table, the same for the old pipe. Different friction coefficients typical for the pipes are given. And we will start with the old pipe. The numbers had already been entered. 8,000 gallons a minute, 26,250 feet of head. Pipe length, 18 inches pipe diameter. 80% efficiency, a first iterated guess on the pump efficiency to be corrected in a minute. And then we'll also show percentage of time the pump operates per year, 100% in this case. And then to the right, we'll see the results. Velocity through the pipe, friction losses, which is equal to our pump head to overcome these losses, and then over 2,000 horsepower that pump consumes and the motor delivers to it, and then $1.3 million of energy operating on stop. For example, if I change 100% to, say, 40%, you'll see the energy reduced to less than $500,000. So let's go back to 100% a non-stop operation. So we need to know what is the real efficiency. So the procedure says make a first round guess on the efficiency, 80%, run pipe loss program, which we just have done, and then run pump efficiency program to adjust efficiency of the pump from now known head, 836.3. So let's say we'll copy that and we'll go back to the website and we'll run pump efficiency program. Now it comes in and we just have to fill the units. 2,000 gallons a minute, a previously used value when the program was run by someone else last time. In our case, we have 8,000 gallons. We can just paste the head from another program, 836.3 feet, 1.0 specific gravity. It was 10 stages pump. We're using one stage in our example. The speed as shown in the article is 1,770, which calculates now almost 30 inches impeller diameter, 83.9 pump efficiency, 2,013 horsepower. We'll now take 83.9% efficiency and put it back, copy that, back into our program. Now let's go to the second line. The first line will be used for comparison as a previous iteration. So we click paste 83.9, and that dropped the energy consumption for 1.38 to 1.31 million dollars. That is basically the process through which we go iteratively to calculate. We just did run number 4, step number 4, we just did a pipe loss program to show what happens when efficiency adjusts. And then we can go back to step number 2 and keep rerunning it until we iterate. So in this case, after 1 or 2 iterations, we usually get pretty close, pretty accurate, reasonably accurate to get the answers. Now, Lee Roos, in his comment, as you see in October issue of Pumps and Systems, mentioned that, well, to our question posted, what will happen if the pipe is plugged up? Half the pipe is plugged up. Well, the half the pipe will make effective pipe diameter essentially smaller. So if we will look and let's go back to our file and open up a little sketch which will show the area and diameter relationship. So here's an area of the pipe. Through open, the area of the pipe is pi r squared. So the area ratio, area after the plugging, and divided by A1 before the plugging, essentially proportional to the ratio of diameters squared. Or conversely, diameter ratio is proportional to square root of the areas. So if we have doubled the area, or half the area, we have to take initial diameter 18 inches divided by square root of 2 to get 12.73. That's effective diameter when the area becomes half of the original area. Well, let's take this number, 12.73 was it? And we'll put that number here, 12.73. Wow, that calculates $7.4 million. Very substantial increase in 11,000 horsepower and at efficiency 83.9. But we want to adjust efficiency right now because the head now changed. More friction. So let's take 4,726 feet of head. Let me copy that into a pump program back to here. And now let me copy and paste 4726. Now, Lee Lewis suggested in his article that a single stage, if we remain with a single stage pump, it will have to be almost 60 inches, 5 feet impeller. Doesn't seem like practical. So at least suggested to change it to, say, 6 stages. If we make it 6 stages, whoops, diameter of the impellers dropped to 28 inches, almost the same as prior to pipe pluggage. And now the pump is 84.3% efficiency. So we'll take this new number, 84.3, copy that back into our pipe program. Let's put it over here on this line and paste that. Now 83.9 became 84.3. And then with that, we'll have 12.3 also copied here instead of 18 inches. Copy 12.3 and paste it here. And we'll see that the real number now went down a little bit, $7.401 million at 11,325 horsepower. Quite a big pump, obviously. The numbers perhaps are a little bit exaggerated because the line is plugged in half, quite significant blockage. But you can see what happened. In order to pump the same flow as before, we need to consume a lot more energy, almost $6 million difference between initial number and the last number. Let's put 18 inches back here. You can see the difference. 7.4 minus 1.3, almost $6 million. In most cases, in many cases, the pluggage is not quite as significant. Let's say, for example, the pipe only becomes 17.5 equivalent. Well, the energy went to $1.5 million. Well, you can use this process continuously several times until you get the answers for your particular case. Or let's say also, instead of 100%, you're only running it, well, let's make it 16 inches pipe and only 25% occupation of pump a year. Well, that dropped the number substantially. But if we change 100 to 50 here, or 25 here, we'll see the numbers now are more realistic to this particular modus operandi. Let's say the pipe becomes shorter. 26,000 feet becomes only 10,000 feet. Whoops, the energy dropped. So you can play with these numbers, quote unquote, and calculate different values depending on your particular conditions and get pretty good, at least first estimate on the effect of the friction in the piping and the pump you will require to overcome these losses. Now, in real case, when the pipe is getting plugged up, the system curve will change, which will push the pump, as we spoke in other modules on Pump Video Academy, at a different flow. But we're not covering in this particular module that effect. We'll talk about it in the follow-up issues of Pump Video Academy. But in this case, we assume that the pump is replaced or modified, repaired, upgraded to provide the same initial flow to a higher pressure, the higher head that resulted from a pluggage of the pipe. Quite significant. So with that, we will conclude our presentations, and you'll find it at pumpingmachinery.com under the Pump School tab of the examples of programs. And then if you for your feedback, for your questions, and for your suggestions and challenges perhaps, write us emails to us at Pumping Machinery at drpump@pumpingmachinery.com. And for more details on that, please come to our Pump School. And the schedule of a Pump School is also shown on our website. The next one happened to be in September, but by the time you see this video, you probably will be past that. So the class after that in the U.S. will be in January 2015, and there's also several other events going on, which you are welcome to review on our website. Until then, keep on pumping, and we'll talk to you soon. I look forward to hear from you.